Excuse me. Good. Hello, folks. Today we're going to talk about how to solve problems dealing with falling objects. And this is, again, still in motion. So when we look at what equation to use, it depends on what we have. And we can use any equations in the previous 5 videos. But there's something we need to know of this, and that the acceleration is going to be known. And that's the acceleration of gravity. It's going to be this value minus 9.81 times 9.81 meters per second squared. So we have the acceleration. That is known. So let's look at a problem and see what we need. All right, so here's an example problem. Again, you're going to have some background information. So what we mean by background information, so when we look at this, we're talking about a building that was finished in 2002. And it's going to be the tallest building in the world. So this is just background information. So if I draw something down here, here's a building. And we know it's tall. And we got a guy up here. And what we have is this construction worker is on the top floor, and he knocks a wrench off the ledge. So this ledge is, say, it's a little bit out, and it's going to go. The wrench is going to go straight down. So the wrench is going straight down, and it's going to be accelerating at minus 9.81 meters per second squared. Now, here's the why it's minus, because what we're doing is that here's the top. Whenever we look at values, at positive and negative values, we have a direction here. Up is going to be positive, down is going to be negative from the point of view, depending upon your point of view. Now, we're looking at this is going straight down. And we have a time, 9.56 seconds. So we have a time, and we want to know what the distance. And here's something, for most of these problems, there's nothing pushing it back. There's no air resistance. So just gravity pulling it down. So what equation do we need to use? So this is what I want you guys to do. Come on, pen. So we're looking for distance. And we know we have time, and we have acceleration. So one of the equations that can fit is when we have initial velocity times time plus 0.5 acceleration times time squared. Now, this is going to go to 0 because we know that the initial velocity is 0. It's going to start at rest. We're looking for this, so we're looking for our distance. Now, 0.5 times the acceleration. Well, we're given that. Let's go back over here. That's 9.81. And it's going to be negative meters per second squared. And we're going to multiply that by time. Now, the time is going to be 9.56. And don't forget to square it. So here's the equation. We've got this. It's fairly simple. No changes, no converting. So let's take a look at how we're going to calculate the answer. 0.5 times 9.81, negative 9.81 times 9.56. And the answer is going to be minus, whoops, I forgot to square. Let me redo this again. Make sure you square. So 0.5 times 9.81 times 9.56, and that number squared. And the value is going to be negative 448 meters. Now, what does this negative mean? So if we look at our building here, if this is 0, it's going down 448 meters. Our height going up is going to be 448 meters, so that's the height of the building. So just changing our perspective a little bit, and that's fine. And again, this is what I want for the answer. Unit, give me the value. If you give me the negative sign, that's fun. You know, negative, the distance, the direction is important. If you have any questions, see me at Scott time or after school, and that's it.